You stop moving. You sit down. Your heart is still pounding. And your skin, it's radiating heat like a furnace that nobody turned off. Why? You didn't do anything wrong. Your body is doing exactly what it's supposed to do. But here's what almost nobody stops to ask. What exactly is still running inside you? And why won't it just stop? Today, we're going to find out why your body keeps generating heat long after the exercise is done. What hidden machinery is still firing inside you while you sit completely still? We'll explore what the science actually says is happening at the cellular level. And then, the part that genuinely surprises most people. We'll look at what that ongoing heat tells you about your body's relationship with oxygen, and why the answer rewrites how you think about rest itself. Here's the setup. When you exercise, your muscles are burning fuel at a furious rate. Your heart rate climbs, your breathing accelerates, your temperature rises. All of that makes perfect sense. But then you stop. And none of those systems just slam off like a light switch. The heat keeps coming. For minutes. Sometimes hours. And there's a very specific biological reason for all of it. Every movement you make starts as a chemical reaction inside your muscle cells. Tiny structures called mitochondria take in oxygen and fuel, mostly glucose and fat, and they convert that into usable energy. But here's the thing about chemistry. It is never perfectly efficient. Every single time your muscles use energy to contract, a meaningful portion of that energy doesn't become movement. It escapes as heat. That's not a flaw. That's just physics. If you could see yourself through a thermal camera right after a hard run, you wouldn't look like someone who had stopped exercising. You'd look like a portable heater. Your core temperature doesn't snap back to normal the moment you step off the treadmill. It lingers. It bleeds heat outward through your skin. And the reason for that is a process your body launches the moment the workout ends, one that most people have never heard of. Scientists call it EPOC, excess post-exercise oxygen consumption. It's sometimes called the afterburn effect, and the name alone tells you something important. After a workout, your body is consuming more oxygen than it normally would at rest. And wherever oxygen is being consumed at an elevated rate, heat is being produced. Your body is not done working just because you are. So what exactly is burning through all that extra oxygen? This is where it gets genuinely interesting. Your body has just been through something disruptive. Your muscle fibers are slightly damaged. Your oxygen stores, the ones bound to a protein in your muscles called myoglobin, those have been depleted. Your internal chemistry is temporarily out of balance, and your body has launched a full repair operation to fix all of it. One of the first things your body is doing is clearing lactic acid. During intense exercise, your muscles produce lactic acid faster than your body can process it, and that acid has to be removed and converted into something usable. That conversion takes energy, which produces heat. Meanwhile, your body is also working to replenish adenosine triphosphate, ATP, the molecule that is essentially your cell's universal currency for energy. Rebuilding those stores costs more energy. And then there's hormone rebalancing. Exercise floods your system with epinephrine and norepinephrine, the hormones that sharpen your focus and drive your muscles harder. Those hormones don't disappear the instant you sit down. They stay elevated, keeping your metabolism running hotter than normal. Your body is in recovery mode, and that mode runs on fuel, which means it runs on heat. Now, here's where the numbers become fascinating. Depending on the intensity and duration of your workout, the afterburn effect, EPOC, can last anywhere from about 15 minutes all the way up to 48 hours. 48 hours. Think about that. You could finish a tough workout on a Monday night, and still be burning extra calories, still generating extra heat when you wake up on Wednesday morning. Your body is still catching up. But not all workouts trigger the same response. A gentle 30-minute walk barely disturbs your body's chemistry. A high-intensity interval session, short explosive bursts followed by brief rests, can push EPOC to its maximum. Research consistently shows that high-intensity and anaerobic exercise produce a significantly greater and more prolonged afterburn response than lower-intensity workouts. The harder you push your body out of equilibrium, the longer it takes to pull itself back. And here is the part that genuinely reframes how you think about this. We tend to think of exercise as the active part and rest as the passive part. Exercise is when the work happens. Rest is when nothing happens. But that framing is completely backwards. Rest, after intense exercise, is when some of the most metabolically expensive work your body ever does is quietly underway. The stillness is an illusion. Underneath it, your cells are in full emergency repair mode. Consider what muscle repair actually requires. When you exercise intensely, you're creating tiny microscopic tears in your muscle fibers. That's not an accident. It's how muscles get stronger. But repairing those tears requires energy. Your body has to synthesize new proteins, rebuild the damaged structures, and reinforce them so they can handle more load next time. Every one of those molecular construction jobs generates heat as a byproduct. And this is still happening while you sleep. Hours after a serious workout, while you're completely unconscious, your body is still running its repair systems. Your temperature is still slightly elevated compared to a normal rest night. You are burning more energy than you would on a day you didn't exercise. Not because you're moving, but because your body is rebuilding, restocking, and rebalancing. Sleep after hard training is not rest. Now, here's something worth sitting with. Even on a day you do absolutely nothing, no exercise, no stress, just existing, your body is still producing heat. That's your basal metabolic rate at work. The energy required just to keep you breathing, keep your heart beating, keep your cells alive and communicating. Your body is a heat engine at baseline, every hour of every day. Exercise just turns that engine up, and it takes time to wind back down. Think of it like a campfire. You pull the burning logs apart. The flames go out, but the embers keep radiating heat for a long time afterward. Because the combustion process doesn't end the moment the visible fire does. Your body works exactly like that. The exercise, the visible, effortful part, can end, but the biochemical combustion that was supporting it keeps releasing energy, keeps producing heat, until every system has returned to equilibrium. So the next time you stop after a hard workout and feel that heat still radiating from your body, you're feeling something real and specific. You're feeling your cells clearing lactic acid. You're feeling your oxygen stores being restocked. You're feeling your hormones recalibrating, your muscle fibers being stitched back together, your ATP reserves being rebuilt. You're not just cooling down. You're witnessing your body running one of its most sophisticated and expensive programs. And that leads to a question worth carrying with you. If your body is this relentlessly active during what looks like stillness, if rest itself is metabolically expensive, if even sleeping is rebuilding, then what does it mean to truly recover? What does your body actually need from you when it's running all of that repair work in the background? And are you giving it enough space to finish the job? If you'd like to keep exploring questions like that, stay tuned. There's plenty more going on inside you than you might think. Subscribe, and I'll see you in the next one.